I'm the professor in this class, and I'm really excited to be here because I love statistics, and I love teaching statistics. And I know some of you are also excited about statistics, but some of you are a little bit nervous about statistics. So mainly, one of the main points I want to make today is you're going to be fine. You're going to understand what we're doing, even though it's going to be some hard work. So what I want to do today is I want to just introduce you a little bit to the course, because this is a really unusual course in that we're going to be doing stuff that I've never done before, using materials I've never used before. And I want to make sure everyone is registered on the platforms we're using this course. So that includes Canvas system and Whole Everywhere. And then I also want to talk a little bit today about statistics and what statistics is and the way we're envisioning statistics. And then I also want to talk about course requirements and grading. You should definitely read the syllabus for this course this week. In fact, you might even want to read it today to make sure that you don't get behind on any of the requirements, because we assume you're going to read the syllabus. Have a seat. So I thought I would start, though, by just telling a little bit of the story, my own story about how I got to this class today. And that story starts with my own learning of statistics, which I never took statistics. I know many people here have had statistics courses before. How many people have had an actual college level statistics course before? Yeah, that's great. I'm always amazed by that, because a lot of the students who come into my class have had college level statistics, but they don't really remember very much of what they learned in that class, even if they just took it recently. And that's something that really fascinated me. When I first took statistics, I took it in graduate school, and I had this amazing teacher. You're not going to get a teacher like him. His name was David Cranes. And I just remember being blown away by a lot of the concepts I learned about in that course. And I actually remember the day I learned about the central limit theorem, which is the nerdiest thing ever, I know. But I remember it as though, you know, a loved one was killed in a car accident and I was there. It's that vivid to me. I thought it was such an amazing thing. I'll never forget it. But it also reminds me of when I was in elementary school and I first started learning math. And when I was in 4th grade, my teacher taught us long division. And I had this stubbornness. It didn't make sense. I couldn't do it. And I was not a very fast learner. And I'm still not that fast. But I really wanted it to make sense. And the rest of the class moved on, because she just taught them step by step how to do it. You know, you just write the number here, you move this number over, you cross out that one, you do this. And I could do all those steps, but if it didn't make sense, I was just unwilling to move on. And I still remember my teacher was very frustrated with me, because I kept saying, wait a minute, I got to figure this out. And eventually, I did figure it out. And that became sort of my modus operandi going all the way through school, is I didn't always get great grades in math, because sometimes it took me a long time to figure something out. But I just wouldn't move on if it didn't make sense. And then fast forward, I grew up, sort of, and became a psychology professor. And I started doing research on teaching and learning. In particular, in my early career, I did a lot of cross-cultural work, looking at how mathematics is taught in Japan and the United States, and China, and looking at students in elementary school all the way up through community college. And one of the things I found looking at community college students is many of those students were not like me. So when they were in math class, they thought they could just memorize all the steps and the rules, and pretty soon they would know math. But it turns out you never learn math if you try to memorize it. This is really a cruel thing, because the smarter you are, the further you can go with just memorizing things in math. And then at some point, you just can't remember all that. You learn all these different things and you forget where they're supposed to go, and they're a little bit buggy and they fall apart. But if you understand things, it's an incredible gift, because the math knowledge and statistics is related to math. It's not the same. But it's, if you really understand it, it's incredibly useful in all kinds of different situations in life, and not just the job you do, but just the way you think about the world. And it's exciting. You can make a great contribution if you understand. But many students don't get there. And they don't get there for two reasons. First of all, they don't get there because a lot of students assume it's not going to make sense, so don't even bother. I'm not going to ask anybody to raise their hand. But if you have that assumption, then you can't really get that far. And so one of the things I'm going to really encourage you to do in this class is to be like I was in 4th grade and just insist on it making sense. I'm not going to ask you to do a lot of things. I'm not going to ask you to memorize things. I'm not even going to ask you to do a calculation. I'm going to ask you to do much harder things than that, like really understand concepts and learn how to write some R code and all kinds of scary things. But I'm not going to ask you to move forward if you don't understand. So one reason students don't understand is because they don't know they're supposed to. And hopefully you're going to know that. And then the other reason students have trouble understanding math, because I spent years studying math teaching, is that actually it doesn't make any sense. Math teachers have been telling you since you were kids things that make no sense. Like, I've seen teachers do things like solve for x, and the student writes on the board and says 35 equals x, and the teacher says, you know, it'd be more correct if you wrote x equals 35. Is that more correct? No. What does a student think when they see that? They go, oh, that doesn't make any sense. I guess math doesn't make any sense. And that happens over and over again. So we're going to try to address that in this class in two ways. First of all, we're going to try to encourage you to insist on things making sense. I want you to be curious and try to figure things out, even if it's hard. And it will be hard. And then I'm going to try to figure out how to make statistics make sense, which turns out to be a really hard thing to do. But I thought I would show you first this study, which I really like, since this is a psychology class, about what they call ritual learning in infants. And the reason I'm showing you this is because even infants figure out at 14 months of age that if something doesn't make sense, you better just memorize it. So this is a really cool study where they had a researcher and two conditions randomly assigned. In one condition, she had a blanket wrapped around her shoulders and her hands were down here, and she was holding the blanket on and shivering. And the infant was seated opposite her, and she did this. She leaned over with her head and hit the button that you see, and the lights turned off. And then she leaned over with her head again, hit the button, and the lights turned back on. And then the infant was told, okay, you can try it. And the outcome of interest was, what did the baby do? Were they able to imitate the experimenter? In the other condition, the experimenter had the blanket on her shoulders, but her hands were out on the table. But she did the same thing in that condition. She said, she hit her head on the button, and the lights turned off. She hit her head on the button, and the lights turned on. So what happened is really interesting. These babies figured if that lady's hands are holding the blanket on so she doesn't freeze, that's the reason she's hitting the button with her head. So in that condition, the babies just reached out with their hands and hit the button, and turned the lights off. They didn't imitate the experimenter because they saw the reason why the experimenter was doing what she was doing. But in the other condition, they thought, oh, she has her hands on the table and she's hitting the button with her head. I better hit my button with the button with my head, even though it doesn't make any sense, because this is a game where it doesn't make sense. And I think a lot of math teaching has become a game that doesn't make sense. And it's partly your fault and partly your teacher's fault. And some of you, it doesn't apply because you figured out math all by yourself. But for a significant number of you, you got to just dig in and figure out math now. And you can. It's really going to be cool. So over the past several years, I got really interested in how we make statistics something that you can understand. And I started working with a colleague of mine who you'll probably meet at some point this quarter. Her name is Professor Ji Sun at Cal State LA. And neither of us are very good at statistics, which turns out to be a real advantage. Because people who are really good at things, and they write it all up on the board, and they look at it and go, oh, look how brilliant I am, that's fantastic. And you look at it and it doesn't make any sense because you don't understand what they're doing. They're not the best teachers. But if you can get somebody who's not very good at statistics to try to figure it out, that's what we have to offer. So G, Professor G, Dr. G and I, spent the last 3 years working on figuring out how to make statistics more understandable. And last year we started work on writing our own textbook because we thought all the other textbooks just didn't fit with what we were developing. So you're going to be using for the first time this online interactive textbook. And it's really different than any other statistics class you've ever taught, you've ever taken. A lot of the topics are there, but the way it's all put together is going to be very different. And it's going to require a lot of effort and work, as you're going to see, because you're going to be learning all kinds of stuff and answering constant questions and testing yourself. And we'll talk more about how that's going to be. So memorizing might help you get through a test, but it's not going to help you get through our tests. You're going to have to think, and you're going to have to understand. And I know you can do it. I literally know you can do it, because I did this last year with a group of students, and they understood, and they didn't even have a textbook that fit with what we were trying to do. This is a really cool book that I recommend, Jordan Ellenberg, How Not to Be Wrong. If you get interested in some of these ideas, you might want to take a look at this book. But he talks about math, and he has a 2x2 table. The top row is profound, the bottom row is shallow, and then the columns are simple and complicated. And he says, you know, a lot of math that you learn in school is in that lower left corner. It's simple and it's shallow. So you learn it, but it's not such a big deal. And it's not that useful. And then a lot of times what happens in school is we move across that road to the right. And we have things that are shallow, not very interesting or important, but they're really complicated. And a lot of algebra that you get in school starts to look like that. I mean, I'm not a big fan of some of the stuff you have to learn in school because some of that complicated algebra, you don't really need it. What you really need is to understand what you're doing and not simply how to manipulate symbols, which increasingly computers are able to do. But statistics is in the upper left corner. Is that right? It's what Ellenberg would call simple and profound. The statistical ideas you're going to learn about are really not complicated ideas, but they're incredibly useful, and they can apply across all different parts of your life. So let's stop there and do a little nitty-gritty on getting ready for this experience. So, how many people have not registered for Canvas? Raise your hands. I'd like you to go and do that right now. Did you bring a device that you can use for that? Just take a minute and go in. Yes? Excuse me? Just do it anyway. Are you hoping to take the class? Won't hurt you. I promise it's not going to hurt you. No, go ahead and get enrolled. And I know that it's very complicated because we're trying to put together all these different technologies, and sometimes they don't work. So I tried to tell everyone, please register with your UCLA email address, the one that my UCLA has on file. And some of you actually did that, which is great. Thank you. And some of you just didn't see that part. And some of you did it, and it just didn't work for some reason. So don't worry about it. It's all going to get worked out. But if you're registered for Canvas now, you should keep using the email that you're registered on. I've been trying to get some people to switch over to an email address that's easier for me to handle. But at this point, just use whatever email address be registered in Canvas. Okay? Are people registering for Canvas right now? Use that code. Definitely use that code or you won't end up in our class. Does anybody have any questions while we're waiting for a couple of people to register for Canvas? Yes. That's the one I prefer you to use. Because that actually is your official MyUCLA email. It may not end in ucla.edu, but it's the one that the registrar's office. You gave them at some point. Yeah. Okay? How are the people doing on Canvas? Anybody need more time? I tried to give everybody a chance to do this before. Okay, and as those of you know who have gotten the emails and have gotten registered already, there's a module 0, I think it's called in Canvas, which includes a student survey. That needs to be done right away, this week. Okay, so the next thing I want to do is get everyone registered for Poll Everywhere. How many people are not registered for Poll Everywhere? Okay, that's more of it. So the way you're going to get registered for Poll Everywhere is you're going to go to polleverywhere.com and you must use, actually, you know what? I'm going to do something to make it easier. The fact that so many of you are not registered means I'm going to if you go to polleverywhere.com and register for an account, you must use the same email address you used to register for Canvas. So hopefully you know what that was. This is a good time to introduce the TAs. We have 3 TAs for this class. Stacy, very popular today. And Stacy, the internet is like so slow. Is it? Yeah. It's unbelievable. Somebody warned me about that. And I got the IT people to check it out and said, it's fine. Is anybody else experiencing slow internet? Yeah. Okay. That's okay. We're going to get it worked out. We also have Adam, second TA for this class, and Laura.
I'm back here. Hello.
Sorry to take time in class doing this, but what I found in the past is if you don't take time in class doing it, it's really hard to make it work. On the other hand, usually the internet works better.
Stacy, go ask him if he knows the screen's not on, if that's on purpose.
I know, because I'm just doing it.
Okay.
Canvas. Okay, one thing I discovered is that if you use UCLA Web, it works better. You can put Stigler at UCLA. All right. I just sent people another email address if you hadn't gotten one. So if you can check your email really quickly, if you get a message from Poll Everywhere, that will give you a link that you can use to easily sign up. So I would suggest looking for that. If you don't get that email, you can still go to polleverywhere.com and register. But if it asks you for your instructor, you need to put in Stigler at UCLA.edu.
Okay, good to know.
Yeah, I found that UCLA Web worked better than EduRoam. And it requires a login. So, how many people got the email I just sent? Some people did. Okay. So when you go into polleverywhere.com, sign up with the same email address you used to sign up for Canvas, and then if it asks you if you want to register with a presenter, put in Stigler, S-T-I-G-L-E-R, at UCLA.edu. And that should do the trick. What's it telling me?
Excuse me.
Yeah.
So when I type this email in, it's telling
Oh,
me that.
no. They're trying to join the presentation. It's just polling them.
That looks right.
And then in
With
the
those.
slide, I put register.
All right, we're coming to that. All right, yes.
Self-registration.
Stigler, S-T-I-G-L-E-R. That's if it asks you to register. with a
Are you getting the
presenter.
same message?
You are,
At
okay.
UCLA.edu.
Yeah, I think they're brain.
I think if it took you, I think you're going to find out in a second.
Has anyone been able to register on Poll Everywhere? Or are you getting error messages or? So raise your hand if you're getting
Yeah,
a disabled
no problem.
message.
Raise your hand and let's, okay, ask your question. Yes? Did you have a question?
I feel I'm stuck back here. With the camera.
Did you put
You're getting a disabled message?
Yeah, I like change password every time.
Yeah. Okay.
That's okay. You're not going to be anonymous. Oh, boy, I should have told you that. Yes. Register. Poll Everywhere.
Has anyone successfully registered on Poll Everywhere?
This is so great.
You think so?
But we're going to stick with it. Yeah.
Okay. Maybe. Okay. Oh, okay. So you have an account. Looks like.
Did you get an email from
And you're getting the same message?
Poll Everywhere?
Yeah. Okay.
It's okay. How many people still have not? How many people did get an email from Poll Everywhere? Most people got one and registered, right?
Those are different things. I think some people trying to register are getting a message saying the account is disabled.
Yeah, you know why? I think it's because they're supposed to wait and get an email from Poll Everywhere.
Okay.
So literally, raise your hand if you at some point got an email from Poll Everywhere. I know a lot of you did because a lot of people registered over the past few days. All right, and if you did not get an email, I just sent another email. How many people have checked their email? Has anybody gotten one just now? Anybody? That's not cool. Yeah. Well, it's like there's a group account. She's the IT person.
Yeah, I feel like it's gonna be hard though. For me to get.
No, it's not letting. We're going to figure it out. It's not letting them join my class.
I think let's see.
So,
He
let me
might.
see if I
This
can
might be
figure that
something
out.
he needs to do later on. What's interesting is that this is not the new technology. He's used this many times. Yeah. So when you enter it here, you're stopping it at disable. Let's try Stickler, STIG. SER at UCLA.edu. That's, yeah, it's appropriate. Okay, because we're waiting for the email probably. Okay. Can you check in your email and see if you got a Pull Everywhere email a few days ago? Did you use the link for the Pull Everywhere?
So like I'm on like the help section and said to register. The professor's supposed to send a link that has like a certain format. But, like, I checked the link that he sent us. It's like a different format.
Oh, the
I'm
format
not sure if
doesn't
that's an
submit?
issue or not, but like I
Okay.
just noticed that.
Okay.
Okay. I'm not getting the email at all.
Yeah, a few days ago. So you probably got one a few days ago. I think that you haven't received the email today because the internet in this room is.
All right, did anybody get an email?
Oh, okay.
Yes?
So there might be a
Hold on a
formatting issue.
Important message coming through. Yes?
Oh.
No, don't do that. That's a different account. That was,
Oh, shit.
Did you get an email that said go to jstigler@gmail.com? I don't think so. Okay, we're going to have to figure it out. Oh.
I think I should get out. There's so many hands now. Will you set this back up?
Yep. I'm gonna hold it.
Sorry, I'm gonna set it back.
Yeah, they mentioned that. I know who she is, but I don't think it's going to help. All right, so we will solve this problem, but probably not today. So watch your emails and over the next day and try to follow links if you get them. Let's sign up for Pull Everywhere. I'll try to figure out another way that you can get signed up for Pull Everywhere. Yes? What do you mean the app works? Yes? But you're already signed up. You signed up before. Yeah, people who aren't signed up are not going to be able to see the questions. Here is a Poll Everywhere question. And actually, I would like people to respond to it if you can. So this is the way we're going to work with polling during this class. So go into pollev.com/Stigler. You can either use the Poll Everywhere app, is that what you're using? Or you can just use a web browser. And if you don't have an internet-connected device, you can also text STIGLER to that number up there. Everybody getting into this? Who's registered, right? Okay. Who's still working on getting in? All right. All right, we've got like 162 responses. Yeah?
If you go on and like say you forgot your password, it'll send you
It sent you a, but
yeah, if you just say like forgot password.
but had you already
No, I haven't.
registered before? And do you know that you registered for our class? Did it let you,
Yeah, on your presentation.
and it let you respond? Yeah? Okay. So tell us how you did that again. You went to polleverywhere.com.
pollev.com/Stigler.
Okay.
And then it said like you could log in. You click log in, forgot my password, and then it said you reset your password.
All right, everybody got that? This sounds like it could work. Go to paullevy.com/Stigler if you don't have a login yet. Say you want to register and that you forgot your password. It will send you a password reset, and then you'll be logged in, according to one student. So, everybody try that, who wasn't able to get logged in before, or registered with our class. I didn't expect this would take like a whole class to get everybody. Did anybody else find that successful? Raise your hand. Yeah, that worked? Excellent. So everybody got that? All right, now everybody should have a way to get registered, provided that works. Be sure to use your email address that you use to log into Canvas, because I don't think it'll let you in if you don't do that. Anybody else have success with that? No? Did anybody have that fail? You guys are very responsive.
Well, I think
Yes.
it's letting students respond to the poll, but they're not yet sure if they're enrolled in your course or just accessing this poll anonymously or.
It's not supposed to let them access it anonymously.
Then they
So I
can't
think
access
that
it.
means it
Yeah.
found their email address that had been uploaded from Canvas and is letting them reset their password. So that's great. All right. All right, let's try another poll. But is anyone still working on registering? It's not working? Did you do? Had you signed up for
Is everyone
You
okay?
did? Oh, before. And you couldn't just log in.
Yeah, it seems like you just go to that link. You see where it says respond at.
Oh, so you just registered today for Poland. Oh. All right, well, we'll have to work that out. All right, let's go with one more question while you're waiting. And that is, what is statistics? What words or phrases come to mind? So this is an open-ended question. And provided we get Poll Everywhere to start working, we're going to be using polling a lot because it's the only way I can figure out what you guys are thinking. Clearly, you're not going to tell me. You're kind of quiet so far. So we'll be using a combination of multiple choice questions, but also open response questions. So go ahead and just write, what is statistics? Wow. We're getting there. So how many people are still not able to respond to this? Boy, we're getting down. Okay. You guys should send me an email later if you were not able to respond today, and I'll try to troubleshoot. All right, let's see what you guys said. This is so interesting. I did this last year, and it looks almost identical. I'm looking at a lot of the words there. Data is the big one. Statistics is kind of cheating because I said, what is statistics? And by the way, none of these are anonymous. No responses in this class are anonymous. So if you think you're really clever, don't be clever. Because it just comes through and tells us who said, you know, like what was it last year? Oh yeah, somebody wrote, bitch ass. Yeah. But, you know. So let's go on and talk about statistics a little bit and what statistics is. And a lot of these things are words that you've learned in a lot of other classes: experiments, mathematics, samples, population, between, mean, averages, trends, interpretation, and so on. And a lot of these are things we're going to study in this class. And if you look at this list of things, I'll bet many of you have studied these things before. So just take a look. Statistic, parameter, sum of squares, variance, standard deviation, t-test. How many people have studied a lot of these things before? Right. How many people think they could explain them right now, what they all mean and how they're related to each other? That's good, because that's what we're going to learn to do. What we're going to do in this class is the work that we did to try to make this class coherent was to go in and analyze statistics. One of the things that we learned from previous experiences with students learning statistics is they learn all the differences across these different statistical tests and terms and ideas. And in fact, in the back of a statistics textbook, they often have like a tree diagram. And you may have seen one. It says if you have an independent predictor variable, a categorical predictor variable and a quantitative outcome variable, then you should use a t-test. Unless you have 3 groups, then you should use an ANOVA. If you have continuous variables, you should use a regression. And what we find is that a lot of statistics courses teach you very much about what's different across all these terms, all these distinctions. But they don't teach you what they all have in common. And if you don't learn what they all have in common and how they're connected, then you're not going to be able to apply them correctly in new situations. Because what happens is you get ones that you don't see how they work in relation to each other, and you make mistakes when you apply them. So everything in this class is going to be oriented around these ideas right here. It's actually, I guess you could say, 4 ideas. So the big idea in this class is modeling. How many people here know what a statistical model is? Could you describe that? Have you ever heard the term? Have you ever heard people say, well, we modeled it? Yeah, that's what I heard. I remember, when I first heard the word modeling, I didn't know what it was, but I was already pretty advanced. So I thought, I better not ask, because that'll make me look really stupid. So I never really knew exactly what that meant for years and years and years, even after, I had a job and so on. So, but we're going to put everything in this class together around the concept of statistical modeling. And the other concept that's going to be really important in this class is the idea of a distribution. And I'm sure you've all heard the concept of distribution, but distribution turns out to be one of the most powerful and important concepts in statistics. And we identified something what we call the distribution triad. And those are those 3 circles around model up there. So on the bottom you have a sample distribution. That's basically your data. And then you have what we call the DGP. Has anybody ever heard of the DGP? I don't think so. Have you ever heard of the population? Sample and population? We're going to think about population and DGP together. DGP stands for the data generating process. That's what we're really trying to learn about in statistics. When we study a sample of data, we're trying to learn about what population did that come from and what were the processes that created that population. And it's those data generating processes. And don't worry if this doesn't mean anything to you today, because these are the concepts we're going to work through as we go through the whole quarter. And then the upper right, my left, you have sampling distributions. And you've all heard of those also, I imagine. But in this course, we're going to try to show how we create models and use models and how we assess models by coordinating together relationships across these different distributions. So even if you've had statistics before, you probably never had to put things together this way before. So our goal in all this is to help you understand. And this is an fMRI image, as I'm sure many of you know, of that guy's brain. That was a joke. That's not really an fMRI image. That's some circles I made on PowerPoint. But the reason we're doing this is really grounded in theories of learning and cognitive psychology. So if you have a lot of stuff in your brain, like this stuff here, A, B, C, D, E, F, G, H, and E, and just imagine someone comes up to you and presents a problem, and what you really need to solve that problem is B, the orange dot. But the thing that comes most to your mind is E, which turns out to not solve the problem. And you have another connection to D, but that also doesn't solve the problem. So you have very few ways to get to B. And if you think about this, connections in the brain amongst ideas and concepts and procedures and situations and the stuff you come across both in your statistics book and in your life, what it means to understand is to be able to connect all these things together so you can more flexibly solve the problems that you're presented with. So on the right is the same guy with a different brain. And he's also trying to get to B. But notice how interconnected his knowledge is. He still has his first strongest connection to E. He goes, it must be E. Turns out it's not E. But because E is connected to D, he can go up to B. Or he can go to D and go to F, and go to A, go back to H, go to F, and back up to B. He has a lot of different pathways he can take to get to that problem. So the theory behind the way we're teaching this course is to try to turn your statistical knowledge from disconnected bits of information over to connected information so that you can pull things together and apply it in new situations. So that's our goal. Our real goal in this class is not for you to just get good grades on the test, which I hope you do, and I really do, but it's to take something with you when you leave this class that you can actually apply in future situations. So that's our goal, to understand. How do you understand? And this is something, there's also a lot of research on. But I've kind of summarized some important points here on this slide. If you look across psychology of cognition, learning, educational psychology, cross-cultural comparisons, it turns out there are three things that are important if you really want to understand. The first is you have to struggle productively. This means that understanding takes a lot of effort, and it's hard. Now, a lot of people have told you about things when they're trying to get you excited. Oh, it's so easy. The problem is, if people tell you something's easy and then you find out it's hard, a lot of people give up. They think, oh, I guess I can't do it. It wasn't easy. It must be easy for other people. But confusion is an important part of learning. I'm telling you this because you're going to be confused in this course. Not just about why you can't get registered and pull everywhere, but even more stuff than that. That's what I'm going to be confused about. But if you don't experience confusion, you're not going to get to understanding. And in fact, it's a never-ending process. That's important when you understand that. The second thing you have to have are these connections. And these connections are not easy to build. You have to practice them. You have to practice connecting together these big ideas like model with the little ideas that you're going to be reading about and interacting with on your online homework, things we're going to talk about in class. You have to be able to take ideas we learned about in your textbook or in class and apply them to new situations. And then you have to keep doing this over time, because as you learn more and more, you need to challenge yourself. And that's really how understanding is going to work. Understanding is just like a skill. Many of us have this idea that skills, you have to practice hard over time. Everybody believes that, right? If I want to become a really great tennis player, I'm going to have to put in a lot of hours of practice, right? And then I have to keep playing people at higher and higher levels. and probably I'll never get to the highest level. But when we think about how we understand things, some of us have a different idea. Understanding, we think, is instantaneous. Like the apple dropped on my head and I went, oh, gravity. I used to use that all the time with my dad when he was trying to help me with my algebra homework when I was in middle school. Because he always insisted on helping me, and no one in middle school really wants their dad to help them with their algebra homework. So I figured out, and I was so devious, that if I sat next to him and I did a little and I said, now I get it, he would be very pleased. He would go, oh, great. And then he'd go off and watch football or something on TV. Totally fell for it. And the reason he fell for it is because a lot of us fall for it. We think understanding is something that if the teacher can explain it just perfectly, it's going to like enter your head, and from now on, your whole view of the world is going to be different. But that's not the way understanding works. Understanding works like other skills. So understanding, especially things that are hard to understand, take place over time. Statistics and the associated ideas are actually pretty hard to understand. They're not complicated, but they take time. So that's what your job is in this class, is to struggle, be confused, stick with it, talk to your friends about it, talk to your professor, talk to your TAs, and just keep trying to figure out how things fit together. So let's talk a little bit about statistics and what statistics is, the way I think of statistics. Fundamentally, statistics is the study of variation. And by the way, before I go on, I hope all of you read about your class notebook. I'm going to give you a little introduction to your class notebook. You may notice that your class notebook is empty. How many people had an empty notebook? Most other people did. Okay. I'm trying to get you guys to respond. So this notebook, we recommend that you use this notebook for all your notes in this class. And you should take notes in class, and you should take notes when you're working through the online assignments. And you should work really hard on your notebook, and I'll tell you why. First of all, there's really good research now that shows if you take handwritten notes, you will learn more than if you type on your laptop or on your phone. Because it forces you to boil things down to their gist. You have to really cut through and say, what's the main idea here? And that's really important. So that's one reason you should use your notebook. Another reason you should use your notebook and work really hard on it is at the quizzes, of which there are going to be 5. I was going to call them 5 midterms, but somebody told me that didn't sound good. We're going to have 5 quizzes and a final. The only thing you're allowed to bring in with you is your notebook, the one that you're going to create in class. So starting from day 1, you should put a lot of energy into making that notebook really useful and beautiful. And the third reason is we're going to give you extra credit at the end of the quarter if you loan us your notebook. Because we're going to study your notebooks and find out how people took notes, whether your approach to note-taking helped you learn more than somebody else's approach, and then we'll give them back if you want them. Yeah, and you'll be able to live without them for a little while. Yeah.
Slides be posted online?
I probably will post the slides online, yeah. But sometimes I don't post the slides online. But one thing you may notice about my slides is a lot of them really don't mean much if you weren't there. So one of the reasons I don't post slides online always is I don't want you to think that you can not take notes in class and go home and download the slides and take notes. It's not as good. Take notes in class, then go download the slides, then work on your notes some more. So that's just my advice. And if you do write a lot in your notebook, try to come up with like an indexing system so you can find the stuff when you're taking a test. but you guys know that already. If you're at UCLA, you're good test takers. Not worried about that. So statistics is the study of variation. And what we're interested in is variation in the world. But variation in the world is really hard to get a handle on. And so the first thing we do is we take variation in the world and we somehow turn that into data. And then in statistics, we work with that data. And by analyzing that data, we use it to help us understand variation in the world. To go back to the distribution triad, you could draw yourself that picture if you want in your notebook. That's really important. So the variation in the world, the data generating process, that's what we're interested in statistics. We're interested in it for two reasons. Number one, it helps us understand what's going on in the world. And often that's really hard to understand. But number two, it gives us the ability to make models that can predict the future. What's going to happen in the future? So when I say statistics is the study of variation, it's actually using variation in data as an entry to help us understand variation in the world and the processes that generate that variation. And then we'll also come later to sampling distributions, which is another kind of variation. Here's a quote I really like from R.A. Fisher. R.A. Fisher was the guy who invented the idea of experimental design. And he had this idea that people always learn from experience. And there's a lot of variation in experience. But often, experience fools you. You learn things that aren't true. We'll talk about that a little more in a second. Experimental observations are just experience planned in advance. Fisher said, if you plan your experience in certain ways, then you can learn more from it. And that's really what experimental design is. In the field of statistics, there are really two different branches. One is research design. That's how you plan your experience. How do you decide what to collect data on? How do you decide what to measure? How to measure it? How do you decide what order you should look at it? And so on. That's design. And that's important to take into account. And then the other part of statistics is how do you actually analyze those data that get put into the data table? So, let's say, in the world, looking at variation, you can think of a lot of examples that are really easy to spot. Like, look around the room. You see a sample of what? What do we have a sample of here? What do we fundamentally have a sample of here? I can't hear anybody. You guys are bashful. Being wrong, by the way, is also an important part of understanding. College students. Brilliant. Fantastic. Thank you. College students. And you look around the room and you can see a lot of variation in different attributes of college students. So you can see race, ethnicity. If we talk to you a little, we might find out you have different native languages. We can look at your hair color and your height. By the way, we can look at your finger length, which many of you, if you've done the first week survey, you've measured your fingers. Very important. And you see all that variation there. But sometimes variation is not easy to see. And those are the situations that are actually even more interesting. So for example, let's take this situation here. Let's say I parked my car in a loading zone because I only had to run in to deliver a big gigantic box of, let's say, 100A UCLA free notebooks. And it was really heavy. So I parked in the loading zone, but I was only going to be there for a minute, and I ran in, and I ran out, and I had a ticket. So, a couple of things here. First of all, did I make a bad decision? How many people think I made a bad decision? Oh, you're not going to judge me, are you? You're still early. Probably a lot of you think I made a bad decision. I just read a really interesting book over the break by Annie Duke called Thinking in Bets. And she made this point really clear, which is that we have to decouple the result from the decision. And that's what statistics is all about. So this result that I got a ticket, where's the variation there? The variation is there because there could have been a lot of other results. I could have not gotten a ticket. I could have had my car stolen. I could have had a lot of different things happen. But the result that happened was I got a ticket. But it's possible that I would not have gotten a ticket. And to understand why I got a ticket, you have to think about variation in all the other possible outcomes that could have happened if I hadn't gotten a ticket. Annie Duke says, in the world of poker, because she's a professional poker player, they call this resulting. Focusing on the result and not on the process that led to the result and the other possible outcomes. She gave a great example. In the Super Bowl, 2015, Seahawks versus the New England Patriots, I think. There were 26 seconds left in the game. The Seahawks were down by 4 points. And they had one of the best running backs in the NFL. 1 yard to the goal line. And it was pretty obvious to everyone, and it was second down. So they had 3 chances to run that ball over the goal line. But the quarterback went in, the coach sent a play in, and said, pass. So the quarterback took the snap, passed the ball, it was intercepted, and the Seahawks lost the game. The next day, everybody said that was the worst call in NFL history. What was he thinking? And what Annie Duke said is, actually, the result was bad, but his decision was amazing. Because what was everybody expecting him to do? Run. So they would be caught off guard. And also, what percentage of passes in that situation are intercepted? Turns out it's less than 2%. So if you look at the decision he was making, based on the variation that would occur across situations like that, it was a very reasonable decision. But he was really reamed for that decision. If he had done the same thing and the pass had been caught in the end zone and they won the game, then what would everybody be saying? That was the greatest decision in NFL history. Her point is, we have to learn how to pull apart the decision process and the result. And a lot of statistics is about that. This is a quote, almost a quote. I made it a little shorter. From Annie Duke's book. There are exactly 2 things that determine how our lives turn out. The quality of our decisions and luck. The key is learning to recognize the difference between the 2. So in statistics, that's often the problem. It turns out human beings are really good at forming causal conclusions. So when the coach called in the play, passed it, it was intercepted, everybody immediately saw, well, the reason it was intercepted is because the guy passed what idiot would pass. So we have that instant ability to cite a single cause. But we're not very good at activating probabilistic causes and thinking about what are the probabilities of all the different things that could happen. And those are the kinds of things you need to keep in mind if you want to think in bets. So, where's the variation here? There's a couple of really important decisions that get made. First of all, if I wanted to think about this situation, I might want to think, what are all the different factors that could increase or decrease the probability that I would get a ticket? Anybody think of some? Yeah. Yeah, if I knew how much time I was going to spend, the longer I'm in there, the more likely I am to get a ticket. Anybody else? Yeah. Yes, if I knew something about the routines of the parking guy. Anybody else? I can think of a lot. Come on. Actually, who the parking enforcement guy was, because some of them are probably lazy, they don't want to get out of the car, throw out a ticket. Anybody else? Did you have one? I could have parked somewhere else, but that would be a different situation, wouldn't it? I'm trying to predict why I got a ticket in this situation. But that gets to another point, which is a really important part of statistics, which is how do we decide which things go into our sample or our population? Because actually, if you think about it, all the people in this room, we could actually measure their height and put them on a distribution and say, wow, look at the distribution of height. But height doesn't really say very much about who you are. Now, it's easy to decide you're each an example of a person. And that makes it possible to think in terms of populations. But when you're thinking about events like that, you have to decide what kinds of situations am I going to lump together. All right, I'm going to move quickly because I see that we're running out of time. This is a metaphor, but how many people know the Miller-Lire illusion? Okay, you look at those two lines, and which line is longer? Now, you all probably know that actually they're the same length, right? But which one looks longer? The bottom one looks longer, right? You can't not see that. You can't not see that as longer. So what do we do about situations like that? Well, if we have a ruler, we can measure each line and know which one is longer. Statistics is like a ruler to help us see probabilistic situations more clearly. Learning statistics gives you the tools in your head to be able to look at something where most people would say bottom line is longer, and you say, wait a second, let me pull out my statistics toolbox and see what it actually looks like. This is really what statistics is. Okay, I'm going to run through a couple of things just about the course before we go. The course is going to be in 4 parts, and you'll see that as soon as you get into the Canvas materials. I'm going to post these slides so you can all read the ones that I don't get to, but my main goal in this class is for you to understand what's happening and also to be prepared for future statistics courses. I bet most of you don't think you're going to take future statistics courses, but I want you to be ready for that. We're also going to be teaching you things that look really scary in this course and giving you new superpowers. On the left, we have R. It's a coding language you're going to learn to use to analyze data. And so at the end of the class, even if you didn't really think the class was very good, you could say, well, at least I learned some R. You can put it on your resume. It's really cool. And you'll be able to write stuff like that. And it's not going to be hard. I don't want you to get all worried because it looks hard. And you're also going to learn some mathematical notation. We call it the notation of the general linear model. And you're going to learn how to interpret equations like that and apply them in statistical situations. The work in this class is going to be done mainly in the online homework in terms of your time. It's going to take 6 to 8 hours a week, I hope. I hope it doesn't take longer. But these are brand new materials. No one's ever used them. And they require a lot. You can't just read them. Literally every paragraph you're going to have to answer questions, write some R code, run a little program, look at some data. So you can't skip through it. I advise you to get started immediately today on the course. 5 quizzes, a final exam, and look in the syllabus because the first 4 weeks the whole schedule is in the syllabus, but you can sort of see how it lays out. This week and next week, week 1 and 2, you're supposed to get through the first 4 chapters of the online material. That's actually a lot. It's one of the heaviest 2-week periods before the first quiz. So I advise you to really get started. All right, you guys, sorry for the snafu on full everywhere. If you couldn't get on, email me, we'll work it out. See you Thursday. I didn't know, right after class. Yeah, you'll see. Turn over.
That's the first lap.
Send me an email. So send me an email when you're logged in, and I'll go and see it.